right, so last part of 7.2, part 2, we're going to take a look at how we can take a formula that has trig in it, like sines, cosines, tangents, inverse sine, inverse cosine. And we're going to take a formula like that and turn it into algebra. And when you have a problem that looks, let me show you an example, something like this. Bless you. And you have inverse trig on the inside. My hint is going to be to start with that trig function that's on the inside, and we're going to set up a right triangle diagram. In fact, I did this to figure out one of the homework problems that someone asked me about. I think the question in the homework said something like inverse cosine of, was it like negative root 3 over 2? And they wanted me to figure that out. Well, I know that the answer is going to come out to an angle. And rather than thinking of it as inverse cosine, I took the cosine of each side, and I ended up with something like this. So I rewrote the function in terms of regular trig, and then I set up a right triangle diagram that represented cosine. So I had to know cosine was adjacent or hypotenuse. That's exactly what we're going to do right here. Same. So we're going to start with the inner trig function, and we're going to set up a right triangle diagram. Now, you're going to know 2 out of 3 of the sides because they're going to give you a trig function. You're going to have a fraction that has a numerator and denominator. If it's sine, that's opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Once you know those 2 sides, you can find the third side using Pythagorean theorem. The third side is the one you're going to need. I didn't have to do the third side in this homework problem because I recognized it as a special right triangle, and I was able to label it 1, 2, square root of 3. If it wasn't a special right triangle, I would have had to figure that third side out with Pythagorean theorem. But the question homework said to do it without a calculator, so I knew it had to come out to a nice answer. So the only way you can draw a right triangle diagram if the inner trig function has inverse trig, like it does right there, you're going to have to rewrite that inverse trig function using regular trig. And the way we do that is usually you take a trig function of each side, and then it cancels out the inverse trig and turns it into regular trig on the other side. Okay, and just remember what the Pythagorean theorem is. Leg squared plus leg squared equals hypotenuse squared, because it's going to come up in the next problem. So that's pretty much it. We need to kind of go through an example so you can see how it's all going to work. But anytime you have a regular trig function on the outside of your problem and an inverse trig function on the inside, it's going to work the same every time, like the steps. Okay, well, let's do this one. All right, so when I'm done this problem, I want to have a formula on the right side that's just algebra. Might have some square roots in it, because we're going to use Pythagorean theorem. Might have a fraction. But we're going to have a formula for figuring this out without any trig at all. And the letter that they put here doesn't matter. Sometimes it's V, sometimes it's X. It's just your letter. All right. So we have an outside function, which is sine. We have an inside function, which is inverse cosine. Which one did I say to start with? Inside. Yep, we start with the inside function.
Why can't you just divide by sine first?
Well, sine is a function. You can't divide by words.
Yeah, I don't think you're multiplying sine here.
And yeah, this isn't multiplication here. Like, just like if I write this, that doesn't mean square root symbol times 3. It means to take the square root function and plug the number 3 into it. So there's no multiplication in this problem. Okay, so let's start with the inside trig function. We're going to forget about sine for now. We'll come back to it at the end. We're going to take the inside trig function. And anytime you use inverse trig, you're always getting an answer that represents what?
An angle.
An angle. That's all that inverse trig is used for. It's used to solve for an angle. So I don't know what inverse cosine is going to come out to, but I know it's going to come out to some angle. So I'll just use a Greek letter that would represent an angle. Now the next step is to, instead of thinking this as inverse cosine, I want to think of it as regular cosine. So I need to cancel out the inverse. What would I do on each side?
Take the cosine of each side?
Yep, take the cosine of each side. So take the cosine of what's on the left, what's on the right. Those cancel. And we get V equals cosine theta. Now, you want to draw a picture for that. You need to draw a picture that's a right triangle. You need to put theta in it somewhere. You can put theta anywhere you want as long as it's not the right angle. And you have to represent this fact in this picture. I know that if I take the cosine, it has to come out to V. What two sides are involved when you do cosine? Adjacent and hypotenuse. So how can you label the adjacent and the hypotenuse? So when you divide them, you get that as the answer.
V over 1.
If you label those two sides just like that, and now take the cosine of theta, it would be the adjacent, which is V, over the hypotenuse, which is 1. And that's exactly what this equation says. So here's the picture. Here's what that means as an equation. So those are the same thing. Any questions up to that step? Now, remember the original problem. This is what we just drew a picture for. I essentially want to take the sine of my picture. Right? We just represented this whole thing as a picture. I want the sine of, we called that whole thing inside there theta. Now to do sine, which two sides do I need? I need opposite and hypotenuse. I don't have opposite. How can I figure out the opposite side in that picture? Yeah. Yeah, we're going to use Pythagorean theorem. So if you want to call it something temporary like x, you can. We're going to get rid of that x in a second. We have x squared plus v squared equals 1 squared. Bring your v to the v squared to the other side. And how would we get x by itself? Square root. So x equals the square root of 1 minus v squared. Any questions on how we got that side?
Is that the final answer for that? You can't simplify it,
Yeah, you can't simplify that.
even though it's squared.
Nope. Because that's a subtraction under a root. Multiplication you could, but not subtraction. Alright, so now we have all the sides we need to answer the question. They want us to take the sine of theta. That's the picture we just drew. The sine of inverse cosine of v, which we call theta. So what's the side that's opposite theta? Square root of 1 minus v squared over hypotenuse. It's just 1. So that is the formula that would do all of that. Let's try it. Pick a number for v. Now remember, it's inverse cosine, so you've got to stay between -1 and 1. What's a number between those two values? 0.5? Okay, so let's do the sine of the inverse cosine of 0.5. And that's what you get. 0.866. Now, let's plug it in here. Let's take the square root of 1 minus 0.5 squared. And you get exactly the same thing. So what we basically did is we converted a formula that had trig into something that didn't have trig. Let's try another one. Let's do like 0.2. Let's pick a different number. That's the sine of the inverse cosine of 0.2. Now plug 0.2 into our formula. Square root of 1 minus 0.2 squared. Same thing. So it gives you a simpler way to evaluate something without using trig. Because when you get to calculus, if you can have a formula that doesn't have trig in it, that's probably going to be an easier formula to work with than one that does have trig. And they mean exactly the same thing. Hey, any questions on that one? All right, let's try the same thing one more time. So this one is the tangent of the inverse sine. When we're done, we're going to have a formula in that box without any trig.
Just in
All right, what trig function do we start with?
What do you mean? Oh,
Inverse sine.
never mind.
And anytime we do inverse trig, we're always solving for an angle. So what could we set that equal to, because we don't know what the angle is? Yeah, use a Greek letter so we remember it's an angle. And now, how would you rewrite that equation with regular trig instead of inverse trig?
V equals sine.
Yep, v equals sine theta.
Alright, so we know that just by using sine theta. We're just skipping that step.
Yeah, we're just taking the sine of each side and then it cancels the inverse sine on the left. Right, now we need to draw a picture for that. In my picture, what two sides am I going to be labeling this time?
Opposite.
I didn't mention the label all, but I'm going to start with opposite and hypotenuse. And what could you make the opposite and what could you make the hypotenuse to make this statement true? V and 1. Which one would be V? Opposite. Now, that's not the only way you could do it. You could do 2V and 2, or 5V and 5. You just have to make it so when you divide the opposite by the hypotenuse, you get V. The best way to do it is usually with a number and a 1. Okay, how are we going to get the third side? Yep, we'll do Pythagorean theorem. After you've done enough of them, you kind of can just figure it out in your head. It's usually like the square root of 1 plus something, or 1 minus something, or something minus 1. You just have to figure it out. So we're going to have x squared equals 1 minus v squared, and x is the square root of 1 minus v squared. I think it's the same thing it was last time.
How did that help?
What's that? So now, what do they really want to know about that angle?
Tangent of square root of 1 minus square.
Well, they want to know the tangent of, what did we call this thing?
Oh, the theta.
That's my theta, right? Inverse sine is my theta. So they want the tangent of my theta. So tangent is what over what? Opposite divided by adjacent. And the only thing they might ask you to do with that is fix it so you don't have the square root in the bottom. And what would you get if you get rid of the square root in the bottom?
B square root 1 minus b squared over minus b squared.
So there's your formula for calculating the tangent of the inverse sine. So you could go through it, you could figure out all of them. I mean, there's 6 different trig functions you could have here. And then there's 3 different trig functions that are inverses that we've studied. So there's 18 different combinations, like the cosine of the inverse sine, the secant of the inverse cosine. You could match them up 18 different ways.
Only 18. That really is way more than that.
Well, there's 6 here, and then there's inverse sine, cosine, and tangent. We haven't studied inverse secant, cosecant, inverse cotangent.
Oh, they added inverses as well. How would you type that in a calculator? You do
We'll talk about it at some point.
cotangent by 1 divided by.
It has to do with flipping something, but not quite the same as that. Any question on this one? So they all kind of look like that. They all have like 1 minus e squared, or sometimes they have a denominator, sometimes they don't. It just depends on which 2 sides you're using. Okay, this is a third one that's kind of the same thing. Does anyone have a question on how you would do this one?
It's the same idea.
Yeah. Start with inverse tangent equals theta. Write it with regular trig. Draw your picture. Use Pythagorean theorem. And write your answer. Any questions on one like that? Okay. So let's do one that's a little different. So that's kind of like the problem in the homework. It says to evaluate without a calculator.
No.
Which means I would be more interested in this problem in the steps. Like there'd probably be a box that would say like to describe how to solve it. Because we know if it's without a calculator, it has to come out to a nice answer. It's not going to be a decimal or anything like that. All right, so let's start like we did before with the inside trig function. But notice this time the inverse is on the outside. So it's not quite the same thing we did last time. So tangent of 3 pi over 4. We're basically just going to do this like order of operations. We're going to start inside the parentheses, see if we can get that answer, and then plug that answer into the inverse sine. What's 3 pi over 4 if you think of it in degrees?
Pi over 4 is 20 divided. It's 45, so 3 times 45.
135. Changing to degrees in this problem, not necessary. We're about to draw a picture and use unit circle trick. If you can do it with 3 pi over 4, then leave it as 3 pi over 4. If you don't know what that is, you might want to change to degrees. Okay, where's 135 in the unit circle?
Second quadrant.
Second quadrant, okay. Closer to the x-axis, y-axis, or in the middle?
Exactly closest to that.
It's
Yeah,
in the
never mind.
It's in the middle.
So that's
So it's exactly in the middle. And when you have it right in the middle, I'm going to draw that triangle bigger off to the side. What kind of triangle did I just draw right there?
oh, it's a circle.
It's a special right triangle. Which one?
45, 45.
That's a 45, 45, 90. Okay, so we've got a 45, 45, 90 triangle. How long is each side in the 45? Well, I don't care about the hypotenuse. I care about the two legs.
It's like, is it 2 pi over 2?
Something over 2, but it has square roots in it.
Negative square root of 2. Square root 2 over 2.
Yep.
Nope. God.
So each side is square root 2 over 2. Now let's write down what the coordinate would be for 135.
Negative square root 2 square root.
So negative square root of 2 over 2. Positive square root of 2 over 2. Now what's your formula for tangent on a unit circle?
Opposite of G.
Okay, so we could think of it in this. You could think of it as opposite over adjacent, or it's y over x. Same. It's the same thing, just different name. What do you get in this point if you take the y value and divide by the x value? You get -1. So that's what this part turns into. The tangent of 3 pi over 4 is -1. If it wasn't a 45, a multiple of 45, or a multiple of 30, you couldn't have done it without a calculator. Okay, so now we've reduced the problem to this. We want to know the inverse sine of -1. So think about that. Inverse sine of -1. Thank you. We're doing inverse sine. So what are we solving for? Because we're doing inverse. We're solving for an angle. If you don't want to think about it with inverse sine, you don't have to. You could think about it as regular sine. What do you get if you take the sine of each side? So I'm basically asking, if you were to graph sine, where does it hit -1? That's what inverse sine means. So think about the graph of sine. Bless you. So you get your marks there. And we're looking where it hits -1. Right there. So where is that angle? That's at 3 pi over 2. Yeah, it combines a lot of things. Oh, yeah. Now, if they said to you to write an answer between -90 and 90, what can you add or subtract from something if it was in degrees?
360.
You could add or subtract 360. What's 3 pi over 2 in degrees? 270. And if I subtract 360, it's the same as -90. It's the same thing, 270 and -90. What's -90 in radians?
Negative pi over 2.
-pi over 2. So either one of these answers is correct. It just depends if they specified write your answer so it is between this and this.
Sorry, how did we find that again?
-pi over 2.
The 3 pi over 2.
We looked at where the graph of sine equaled -1.
Okay.
Or you can think of, yeah, I think it's easiest, I think of it visually. That's how I think of it. And if you don't have to write it this way, if you look at this and you know that this means, put a horizontal line at -1, draw a sine, and see where they cross each other. That's what this means. Okay, so a little bit different, but that one's all numerical. There's no Pythagorean theorem. There was no real algebra like solving an equation there. You did have to know your unit circle trig to figure that out. And then you have to know what the graph of sine looks like to figure that out. All right, let's try this one. Does this look more like the first type of problems we were doing, or the second type?
First.
More like the first type.
Inverse is in the
The inverse is inside. Now, the difference here is when you go through and do the problem, you're going to get an actual answer. That is a number. So it's going to be just like we did the first 2 or 3 problems, but you're going to have all numbers. So it's actually going to be a little bit easier. Okay, go back here. All right, so what trig function do we start with? Inverse tangent. And what do we set that equal to? Theta. And how are we going to rewrite that?
1 over 2.
So the tangent of theta equals 1 over 2. And what do you do with that equation at this step?
Right triangle.
Yep, you're going to make a triangle. But this time you're not going to be labeling things with a variable like v. You're going to have all numbers.
But alright, so why did we use it here? So
In the last one,
yeah.
because we were trying to solve for a trig function. We weren't doing inverse trig, we were doing regular trig.
Interesting. Okay.
The inverse was on the outside, now it's on the inside. So it makes a little bit different how you go about it. I think when the regular trig is on the inside, that's a little bit harder
Yeah.
because you have to remember the unit circle and go from there. Okay, so what 2 sides am I going to be labeling in that picture?
Opposite adjacent.
Opposite and adjacent. And what am I going to label them as?
Opposite is 1, adjacent
1, 2. And hypotenuse is going to be square root of
3.
5.
Wait, what? 4 plus 1.
2 squared is 4. 1 squared is 1.
silly goose.
4 plus 1 is 3. Okay, and now we've got our picture. And what they really want to know is the cosine of the picture. So what's the cosine of that picture? 2 over root 5. This is where we would normally end up with like the 1 minus v squared, square root of kind of thing. But that didn't happen because we had all numbers. And there's your exact answer. If you try to type that in on a calculator, you're not going to be able to do it. Because, what is it, 0.5? It's going to tell me it's 0.894427. Now, if you type in 2 square root of 5, and then divide it by 5, it is 0.894427. But you're not going to recognize that decimal as that number. Because there's an infinite amount of combinations of numbers that could make that up. Any questions on this is another one, just like the last one, with an inverse trig, and it has a number on the inside. Does anybody want to see this one?
I prefer to do another one with just normal trig function inside.
On the inside, did I have another one? I don't think I had another
It's
one.
almost very all over the place.
I could try to make one up, but it's got to come out nice, so that's tough to make up, actually.
Okay. Alright, how many are there like that one in the homework where it's just the actual trig function?
Not as many as this type. The inverse trig on the inside is more common, which is why I spent more time on that.
Yeah, okay, because I don't feel confident I'll be able to solve one of the just trig ones by myself.
So let's see. The homework isn't actually very many questions. Let's just see if there's this one. 390. for 37, 38. I don't see a good one I can do quickly, but if I have time, I'll look at the extra problems and see if there is one. Does anyone want to see another one like the last one? So I think the inverse trig on the inside is easier. And when it's all numbers, it's even easier because then you don't have any variables or square roots like with these or anything like that. Okay, remember that when we're solving trig equations, okay, we've done this before. If you had a wave, and let's say I asked you where that sine wave hits 0.5. Well, that's 1. 0.5 is right about there. How many times does it hit 0.5? Infinitely many, right? So remember, because the trig functions are periodic and they repeat, you're going to keep getting the same answer over and over.
Can you just add 360?
Yep, so that's where, when you write the answer, you have to put plus the period times n. People remember that? Plus period times n. You have to put that on the end of your answer to represent it repeating.
For all of these.
Unless it specifically says to only find answers within a certain section. But if this says all, then you need to put plus the period times n.
Okay, are we going to do that one right now?
Not right now, but yes. Remember, when you want to type something in on the calculator, you may have to use an identity. Like if you have to type in something with secant, there is no secant button. So what trig function would you use to do secant, and what would you do with it? Yeah.
1 over cosecant. Yes, cosine.
1 over cosine. So you'd have to take the cosine and flip it to do the secant. Same idea for cosecant and cotangent. Any question on that? All right, so let's try this one. Right, so sine of x equals 0.6. All right, how am I going to do this graphically? What would I put into y1? All right, so we could put in sine of x. And in y2? 0.6. And we need to set our windows so that we're only looking at one cycle. If you look at more than one cycle, you're going to get confused. You're going to see more than you need to. So what is the length of the cycle for sine? And there's no transformations being done to it at all.
Is it at 180 or pi?
Not
one cycle?
one cycle.
Is it 2 pi?
It's 2 pi. So what could you set for a window that would show you exactly a width of 2 pi?
0 to 2 pi.
Yeah, 0 to 2 pi would be the easiest. You could do negative pi to pi. That's different, but 0 to 2 pi is good. And the highest and the lowest that the sine function is going to go.
What is 1 to 1?
Negative 1 to 1. Okay, so we've got our, I probably should have gone a little higher, but that's okay. So we've got negative 1 to 1. We've got our cycle perfect. All right, so how many answers are we getting per cycle? 2. So how are we going to find the first one? So we're going to do second calc intersect. We do need to move it a little bit closer. That is important. And the first answer is 0.64. And what do we need to put on the end of it to represent the answer that you're going to get, like over here.
That's 2 pi n.
Right, the next one is exactly 2 pi units away from the first one. They're all spaced 2 pi units apart. And n is what kind of number?
A real integer.
An integer. Yeah. So you can add multiples of 2 pi, or you can subtract multiples of 2 pi and get the answers in the previous cycles. Okay, there's your first one. And the second one, we're going to do the same thing. Intersect. Just move your cursor past the maximum, and I think you should be fine. Okay, so that's about 2.50. And how often does that answer repeat?
2 pi n.
Every 2 pi n.
Is 2 pi n just for sign? And yeah,
Just if there's no transformation.
well,
Sign,
but if it asks for like, oh wait, it's just, sorry, we only talked about period lengths and sine.
Yeah, we talked about period lengths with all the trig functions, but this is the formula that you use for sine, cosine, secant, and cosecant. You take 2 pi and you divide by the number in front of x. But there was no transformation, so it was just 2 pi. Does anybody remember what the formula is for tangent? It's pi over b. Yep. Which, that second formula is going to be helpful because we need it right now. So we're dealing with cotangent, no transformations. What's the period of cotangent?
Pi.
Pi. So this time I want to set a window on my calculator that is pi units wide. What's the easiest way to set a window that's pi units wide?
0 to pi.
Yep, I just go 0 to pi. And this time I'm going to put 2.5 in. I meant to put it on y2, but it doesn't matter. How am I going to put in cotangent?
1 divided by tangent.
Yeah. How else could you do it? Besides 1 over tangent.
It's like cosine over sine.
Yep. You could also do cosine over sine. Because sine over cosine is tangent, so if you flip that, it's cotangent. Either way will work. Oh, I didn't set my window high enough. Remember, my window was -1 to 1 on the range, and I've got something up at 2.5. So I need to go. I would say, what would be a good min and max for the range?
3 and -3.
Yeah.
-3 and 3.
Now, there's my line at 2.5. And how many answers am I going to get per cycle?
1.
Just one. So there's your sketch. And how are we going to get that answer?
Calc. So second calc.
Yep. So second calc intersect. And we get 0.38. I'll just put it so you can see it. 0.38. And what do I need on the end of that answer? Plus any multiple of pi. And that will give you the next answer. Any questions on that? Okay, anything else from today that people want to take a look at? No? Everyone feels pretty good with part 2? A little bit shorter. It wasn't actually as long, I don't think, as yesterday. Yeah, it was short.
Oh wow, yeah, by like 10 minutes. It was 49 minutes.
So, homework for tonight. is those 8 or 9 questions. So 37, 38, 41, 42. Well, actually, it's more than that. And then 44 to 53. 37 to 42. That's all like we did at the beginning of class. Those first couple problems. 44 to 53. Maybe I should talk about one of those. What if you had something like this? 3 times the inverse sine of x equals 2. And you're trying to solve for x. What would be your first step to solve something like that for x? Yep.
Sine both sides. Oh, multiply, divide by 3.
Yeah, divide by 3. And now this is exactly the type of problem we've done from here. What would you do on both sides? Yeah, take the sine of both sides. And that's it. X is the sine of 2/3. I don't know if I really had to go through that, but you'll see a question kind of like that one. Anytime you want to get rid of a trig function, just take the opposite trig function on both sides. If it's inverse and you want to get rid of it, use regular. If it's regular and you want to get rid of it, use inverse. Okay, so that finishes up 7.2. And then tomorrow we'll take a look at 7.3.